The idea behind train detection is it's there to help us in our model railway work, to either let us see things or do things based on knowing where things are. I've said things up there because it's not just locals you might want to know the presence of, but rolling stock. So most commonly it is used for mimic panels or control panels. And that's handy when you have a very large layout, particularly club layouts, where people at one end can't see what the other end is up to. They can check what's free. They want to send a loco up the track. They want to know that siding is vacant. They can look and see on their mimic panel what's occupied and what's not. It's used at home. I've seen home layouts use them. One of the members has got a layout in his loft, but it's got a large chimney breast and he can't see behind to see what's going on in his part of his fiddle yard. Or if you've got sidings in tunnels or in cuttings and so on, then what you want to do is to be able to detect the presence of a train or rolling stock and feed that information back. And then use it to illuminate lights or do other things. When I use the word automation here, I immediately clarify it because we're looking at a very simple action. A train comes into a station and the station lights come on. A train goes into a siding and some animation starts. Just one little thing happening on its own, that's a small automation. Or it could be a partial automation where you have trains going around the main loops, but you want to do work in the sidings on goods yards and so on. Or you may want the entire layout to be automated using various bits of software. All of these need some way to detect the presence or otherwise of a train, either rolling stock or the loco itself. There's examples of partial automation that I said earlier. And there's different methods of detection, which feeds into what we'll look at shortly in terms of the actual hardware. Spot detection just means you have one particular spot in the layout and it's triggered when a train comes past it, either moves past it or sits stationary over it. So if you stop your train short of it, nothing's going to happen. You have to precisely have it over the detector, or it relies on movement. As it passes by, it triggers something to maybe change signals or change points or whatever. So that's spot detection. Aerial detection is over, as it implies, a wider area. If it's a wider area, you can be moving through that area or you can be stationary in that area. You can be anywhere in that one defined area and it will know you're there. And then block detection is used to not have discrete components, but actually have a module where the power to the track comes through that module and is detected when you draw current. So that's the methods we're going to use for detection. And two other definitions are occupancy and identification. Nearly all the stuff that we do is based on occupancy. Either the train's in that bit of track or not. Either that siding is occupied or not, which is a very useful thing. If you want to go further, and the very last part of what I'm going to cover today is RFID, where you can identify, you know something's there, but you know what's there. You know exactly because it's got its own code. And that allows you to take selective action. What by that I mean routing, the train comes along, is detected, and can make a point go one direction or the other to follow a particular route depending on the train itself. It can be used to give broadcasts. the train arriving in platform 2 is blah, blah, blah. And we'll look at these. Right, so this is an example, very simple one of what we have for one of our demonstration layouts. So we have that layout, and we've used these, we'll cover these later, but they're current detectors. When the train comes into a particular section, it knows it's there because we've divided that layout up into discrete areas that you see there. We've cut the track and we feed power to each of those through a module. So when a train comes into that particular section in green, then that green light lights up. When it goes through that particular section in red, that lights up. And we have used that on our demonstration layout. You'll see it up there. The layout itself, you can just see it's got a hinged section that covers it for transport, and that doubles up as an area to put up posters, advertising our meetings. But at the very top, it's got the Merg logo, and it's also got a small mimic panel. And as the local goes round, it lights up various sections of that panel. And we've used a C-bus from the layout to get up to the top there. You'll see a little channel away along the left there, taking the C-bus up. Right, so detection can be used for control panel indicators, just like I showed you, for automatic signaling, for automatic points, automatic barrier gates, to initiate animations and so on. There's a whole range of activities, small and large, depending on how much time and how much effort and how much money and how much knowledge you've got to implement them. And there's a small example of a local animation, a local activity. That's one of the pocket money kits. We'll show it later. But the idea being we have a detector, the train hits the detector and the lights change. So there's no good. This was a layout for one of the clubs locally, and he had an up line with a semaphore arm, sorry, signal lights. And there was a switch that people were meant to throw, club members meant to throw to change the lights. And in the heat of battle, I showed they didn't do it. And the result was that kids were saying, hey, your train just went through a red light. So we came up with this as a small pocket money kit. The train comes along, changes to green, lets the train pass that section, then it goes back to red. So, and it's not tied up with your control panel. It's not tied up with any programming. You just build it, wire up your two LEDs, wire up your little detector, and it works. So you don't have to implement a very large detection system to get some effect on your layout. That solved one particular problem for one particular club. We can also have signals. It's the same kit that I was showing for changing lights could instead be used to change signals. So the signal arm would go up when the train was detected, and when the train passed, the signal arm, semaphore arm would come back down again. You'll see just up the top in that small layout, we've got a barrier gate. And it's a train is detected when it's coming close to it. When the train comes round along at the end here, the gate comes down to stop the road traffic, and when it's passed, the barrier gate comes back up. A little animated effect on its own. Doesn't need any other thing apart from the kit that makes it work. Here's another example of a little local animation. You can just see here a little hole in the track. We've got a light detector in there, and we have the water arm here that's controlled by an easy point that rotates a servo. So when the the train comes in, it blocks the light, the crane comes round. And then, of course, conversely, once the train leaves, the light is back on again and it's reversed. So we've managed to get, once again, a little feature into a layout with just a couple of MER kits. One of them being the detector and the other being the action that detector starts. You can even have, if you wanted to, automatic uncoupling, where the coupling ramp comes up and uncouples. Just a servo with a skid on it that comes up, uncoupling ramp comes up and does the business. Once again, small features in themselves, but are very useful. I've added to the list reverse loops and shuttles and so on that can also be using detection, and we'll look at these a little bit later. And sound effects. On that same layout, we've got a sign that says whistle, and as you can imagine what happens, the train comes round, is detected, and a sound player plays a whistle. On that layout, it's written so it doesn't do it every single time, otherwise the other exhibitors would go mad apart from ourselves. So it's designed to only work maybe in every 6th or 7th circuit, but it adds another feature. So it's not just animation, but in lights, we can actually have sound effects too. And then if we get to the clever stuff with computers, we can detect train lengths, the direction they're going in, and have full computer control. So an example, the GMRI, integrating detectors to the software, which in turn controls points and signals and traction and so on. And Rail do something similar, which is for the folk who are prepared to put in the time to learn the software. So that's the background to why we want to have detection for a whole range of lighting effects, sound effects, animations, routing, signaling, blah, blah, blah. So what have we got? We're going to work our way through these this afternoon then, from something that's very simple but useful through to more complex systems. So let's start at the very beginning. Micro switches. They sound so simple and so useful. As it shows there, they come in a whole range of different sizes, different current ratings, different rollers at the top. You'll see some are pure levers, some are humped, some have actually got rollers on them. They're all the same internally. Let's see if you can see one. So that's for typical micro switch. As you can see, they do come in much smaller sizes. The standard one has got quite a bit of pressure to make it work and quite a large amount of movement. And you can just hear a positive click when it does it. Also, while I'm here, there's a tiny leaf switch, which takes much, much less pressure to make it work. And we'll look at the two of these next. So the leaf switch, it's an ordinary switch. They're very small, as you saw. They only handle small current, very low operating force. The downside, unlike a micro switch, they are open to all the elements. So they're not a very good thing to have in damp situations or garden railways or whatever. But where you need very low operating force, very, very useful. You'll see them sold by Pico there. for putting onto the pico points for doing frog switching. Although I'm not sure that £5.50 is exactly the price you'd want to pay. I'm sure you'll be able to find leaf switches a lot cheaper in bulk from our good friends in China. So leaves, they just push them and they operate. That's all they do. So why are they handy? Well, there's another one from Walters who only wants $17 for theirs. Ooh. But they've got two on the one module. And we do the same. We've got our 3D printed mounts for servos, for operating points, and there's two slots there to allow us to fit micro switches like that. So when the points move, the micro switches move to do frog switching or feedback or whatever. So how do they fit in as detectors for locos then? Well, how about that, guys and girls? You couldn't get much simpler than a bulb and a micro switch. The bulb's easy as totty. The train comes to the end, hits a micro switch, and you know it's there. Of course, we're not going to really implement that, but that's a good starting point to see that micro switches can be used for detection in model railways. Those who've seen, this is the layout, one of the other layouts we've got. It's only partly built at this stage here, but the idea is that we have a threaded rod that's going to push a barge along a canal into a warehouse. And when it gets in there, it's going to hit a micro switch, and that will initiate a series of animations on the layout itself. So it stops, the light comes on at the top, you'll see a man come out to see what's going on, and then you'll see the load being lowered into the barge. In that animation, there's 3 places to stop along the way in the canal. And that's all we do. On the threaded rod, the sled that's moving the barge itself also makes contact along the way with 3 micro switches. So it knows where it is at any point. It knows that when it gets to the far left end, you'll see that warehouse animation. It knows when it gets to the middle, it's going to bring a light on in another warehouse, and a lorry is going to reverse out, and so on. It's not train detection in this case, but it's used on our layout to detect positioning. Another use for it that I have, we've got the simple shuttle kit that already exists. It's just simply a 555, and all it does is every so often it reverses its output. We'll switch a relay on and off, and the relay will keep reversing the polarity to the track. Very simple. But I've adapted it to do this. I've got 2 inputs, and I've turned the 555 into a bistable mode, a flip-flop. So it's either in one state or the other. And I've got 2 inputs coming in here from detectors. So if one hits, the relay operates, when the other is knocked off again, and again reversing. So what good is that to us? Well, what I've done, I've got a micro switch, you'll see it up the top here, and I've soldered on an extended paddle, so it takes even less pressure to operate it. And there's my little 555, there's my relay for reversing the polarity to the track. Here's my incoming power here. At the other end, I've similarly got an extended paddle on a micro switch. And I use that as a form of shuttle like that. It hits one paddle, runs to the other side, hits another paddle. I don't use that as a shuttle because the shuttle, as you know, stops at either end. I use that as a way to both check if I put on a lower voltage, I can check how any loco performs at a low running speed. Is it jerky? Is it smooth when I'm working on them? And it's also handy as a local warm-up. Just leave it in the background at a show to run in the local before you put it onto the main layout. And that's just using 2 micro switches. That's the very simplest kind of train detection you can get. Going up market a little bit, we have reed switches. A reed switch, very simple. It's a switch that's hermetically sealed and needs a magnet to make it operate. It's used a lot in burglar alarms. You'll see them if a burglar opens a door, a magnet on the window or a door will open, and the magnet or the release of the magnet makes the reed relay change, bring on the burglar alarm. And other places like wind turbines, fluid levels, and anywhere where you've got a toxic environment. I used to live in Glasgow, and there's a place called Brown and Paulson's. A long time ago when I was a kid, had a huge explosion that killed 4 people and injured dozens. And Brown and Paulson made custard powder, and they made animal feeds. And the result was that the air was full of dangerous and inflammable materials. And a spark caused an explosion from an ordinary switch. So now down mines and in those kind of environments, they use reed switches because they're hermetically sealed. And they're great for us too, because we don't have to worry about dampness or corrosion in the contacts inside because they're hermetically sealed. Great for outdoor use. They're used in model railways. A price, Gauge Master will sell you one for £18 for N scale, and LGB will charge you $35 for a G scale version. And all that's inside these is just a piece of plastic, and inside you've got a reed switch. I don't know why you need to pay £18, gents, to get that, but people do, otherwise they wouldn't make them. And the idea is, if a train has got some kind of magnet, as it passes over, it'll make the reed switch operate, and a signal will come up these wires back to whatever you want to do with it. And down here you'll see again contacts coming out of the module. And at the very end, that's where the reed switch is, under the track, between sleepers. As you can see here, they're charging a fortune in the last slide, but you can buy 10 for £2.32. All the prices I'm going to show you along the way, by the way, gents, are ones I got off the internet just last night. So they're all up-to-date prices. So they're about 20 odd pence each. So if you don't want it to be in a plastic box, you can save yourself a heck of a lot of money. The advantage of reed switches, as you can see here, you don't have to do anything fancy to your layout. Don't need to cut track, don't need to create blocks and sections. You just put it under the bit of track where you want to detect. It can be daylight, it can be night time, you can run in a night run. Doesn't matter what the light level is on your layout, they work. They're very easy to fit. It's just two connections, only 2 wires. Because the downside is that you have to have small magnets on your trains to make it work. You have to modify the trains. You don't have to modify the layout, apart from fitting the micro switch, but you do have to modify the locos or the rolling stock. It does allow you to do, as I said at the bottom there, you can exempt particular trains. If you don't fit a magnet, if you fit a magnet, you can say, when I get to that detector, I have fitted to those particular trains, goods trains. So they will be automatically routed that way. And every other train will carry on. So I'll operate points depending on how I fit magnets to different locos. I said pulsed output, what I mean by that is that you have to be over it or running past it. If you run past it, you only get a pulse while it's going over the reed switch. If you sit over it, you'll keep it contacting the whole time. Right. There's a small example of one. Right, if I go back to that same one, there's a reed switch. There's a magnet. And I'm coming about, what am I about there? About almost a centimetre of a gap there, and it still operates. So it doesn't have to have the magnet very, very, very close to the reed switch, which is good news. I don't know if you noticed, when I showed you the water crane, I had a loco and a little wagon, and the wagon had a load on it. The load is actually a magnet. So what we have here is a basic bit of layout where we put a reed switch here. And when the loco comes in, it'll operate the reed switch, and you'll see a sequence starting. So here it comes. There's the magnet. You'll hear clicking in the background. What it's doing is a point is changing back there. A semaphore arm is moving back there. Now a man's coming out. A light will come on here, and the door will open, sliding door, and then we'll have the crane coming round, and then we'll have a truck coming round here. At the time we did this, it was all done by a pick, but since then we've brought out a kit, a sequencer kit, which will do the exact same thing for us. And all the man, the door, the crane, the truck are all being operated by servos, so they could be happily run by a sequencer kit that we now sell. So we're using a reed switch under the track to initiate a relatively complex set of animations. If we use magnets, we can also use them for reverse loops. That's a possibility. Well, the CDU is going to operate the point, but the CDU itself is switched by reed switches. One of the members came up with this, which is a CDU, and the reed switches will then switch power through the coils. And I thought that's not very good, because reed switches, they vary, in some are like half an amp and some are 1 amp maximum current, whereas point motors, H&Ms and so on, can easily have 10 amps peak. So we don't want to be constantly arcing the reed switches. So I came up with a little mod to put in some power transistors, probably MOSFETs nowadays, and let them do the heavy lifting. So the reed switch still operates, but they operate the power transistors, which in turn discharge the power through the coils of the point motor. And there's one there. That's what we did. I just used 20355, ancient old power transistors, because they happen to be in my cupboard. But you can see here, we've got 2 reed switches, and we'll show it working. Here comes the train. We'll press the point, and it's back for coming out again. We've got a better one as a kit, but that just shows we're using reed switches to operate points if we wanted to. The DCC reverse loop that we market now uses an adaptation of it. It doesn't care what the inputs are as detectors. It could be laser totties, it could be reed switches, whatever you want to use. But it comes in 3 modes. depending how long your train is and whether you want to have timers or better control. We can go into that if you want to ask it as questions. For DCC, you still have to switch the track so we don't get shorts. But DCC being DCC, a local disk says go forward. It's not polarity conscious in that sense. It just keeps going forward. So as long as we switch the track polarity to avoid shorts at the point end, it'll carry on happily in either direction. In other words, if it comes in on the clockwise way, it'll move the point to straight ahead to get back out. If it comes in straight ahead, it'll operate the point to branch to get back out again. So it'll work in either direction, depending how you set the point last time. Doesn't matter, it'll still do a loop for you. And there's a simple version of it there. You'll see up the top right, I've got a laser totty. And then up here, we've got the pocket money kit number 23. And down here, we've got the easy points to operate the point. Got a little chassis with a DCC decoder on top. And we can just have this is a prototype when I was doing the kit before to prove it worked. So I'm just throwing the switch multiple times to show it doesn't matter where it was when you started. In this case, it was straight ahead. Hits a laser totty, operates the point, and it comes straight out. So we don't have to worry. It's just seamless. In that case, I was using a laser totty, but it could be anything you wanted. It's less than £3 nowadays to buy. So not a lot in it. It's only a pick, a transistor and a relay, essentially, and various detectors of your choice coming in. The minimum one is to have one single detector, which is the top here. One in the middle. The limitation of that, of course, is that the train length is determined by half the length of the loop. If you want a bigger one, you can use this one or this one, which the train can be the length of almost of the whole loop. So you use as little or as much of that as you want, depending on how complex you want your loop to be. Hall effect switches are fairly popular. Very, very popular in cars. Are used in a whole number of places because, again, they're sealed units. There's no worry about ingress of anything. That's what they look like. They look almost like a little flat transistor. The 3-wire devices, again, very cheap, 27 pence each. Currently, like a reed switch, it needs a magnet to operate it. It's detecting magnetic flux. It won't switch things by itself, generally, although it can, as long as it's low current, because it's quite a low current output. And I can show you that. The benefits first are, once again, no having to cut the track and create sections or blocks. There's complete isolation from the track. It doesn't affect it. Unaffected by light, again. Comes in 2 flavors. You can get ones that are clean on-offs. In other words, it's either completely on or completely off, or you get ones that have got a linear output. The amount of voltage out depends on the magnetic flux level it detects. And I'll show you that in a moment. Very small component count, i.e. one component. And some can differentiate between north and south poles, which a reed switch can't. So let's have a look. There's a Hall effect switch. Once again, if I just get that same little neodymium, get close to it, that one's operating about, what, maybe about 5 or 6 mil from the magnet. And you can see there, it'll operate from either side. Right. When you're buying them, you've got to be careful. There's various ones. The ones that are called linear are proportional. In other words, the voltage out depends on the flux it perceives. Unipolars only operate if you take a south pole of the magnet to them. Omnipolars, as you'd expect, will work whether you put the north pole or the south pole on it. And then bipolar or latch, they're slightly different, but they do much the same thing. If you present a south pole to them, they'll switch one way and they'll stay in that position. In other words, on, until you put a north pole, and then they'll drop out again. So it's like a latching relay almost. Right, we're used to switches where you simply, it's either off or on. But if you take the linear one, you get a 5-volt range. And when you first put power on it, it sits at 2.5 volts. And depending whether you put a north pole or a south pole, it'll either go higher than 2.5 or it'll go lower than 2.5. So we now know whether a north pole or a south pole has been placed near it. Here's an example using my old Evo 8, because it's a nice screen. We're in a 10-volt range right now. It's sitting at roughly 2.5 volts. And you'll see if I put a magnet close to it. Here I come. The voltage increases. A reversive magnet, and it decreases. A reversive magnet, and it increases. So it depends on which pole you present to the object, whether you get an increase in voltage or a decrease in voltage. We could use that. That's a very simple way to do it. You put a north pole at the front and a south pole at the end. So when the train comes in to that section and passes the Hall effect switch, the output drops below 2.5. And then once the local passes, goes back to 2.5. But when the last wagon passes, it goes above 2.5. So you now know various things. You know, for example, that train has been detected. But more important, you can tell the speed if you wanted to. Just measure the time between when did it go below 2.5, when did it go above 2.5. And also direction. If it went low first, followed by high, it was going leftwards. But if it went high, then low, then it's going rightwards. You can tell direction as well as speeds if you wanted to using Hall effect sensors. And then there's the latching effect ones, which are more expensive. They're about 80 pence each, as you see. But it depends whether you put a north pole or a south pole to them. You could try that same thing. Only this time it's going high and low. This time the output goes low and stays low. So if you put a north pole on this train and you're coming up to a barrier gate, for example, or a signal, the barrier gate will activate for the length of the whole train and is only switched off when the south pole comes. So the output from the device can go straight into an easy points, for example, to operate a barrier gate. So one Hall effect, a couple of magnets and an easy point, and you've got automatic, and it's automatic whether you have a short train or a long train, as long as you've got a magnet at either end. There's no kit for this, although Mike Bolton did do something some time ago You'll find that in the forum somewhere tucked away, using the Hall effect to good effect, feeding the value into an analog port of a PIC. And then either the yellow light comes on or the green light, depending on whether it's received a north pole or a south pole, and then two outputs to handle it. Right, probably more familiar territory for most of us is light detectors. That's what it says in the tin. It's a light-dependent resistor. The amount of resistance between the two pins depends on the amount of light that's shining on it. Pretty cheap, 30 pence each. They work whether it's locos or rolling stock. Anything that blocks the light works. Again, no mods to your track wiring apart from fitting it somewhere on the track. You can mount it, most people mount it on the track itself so that the loco comes across and blocks the light to it. But it could be above board. If it's in a tunnel or something with its own light source. Very cheap, doesn't matter whether it's a whole train, a single loco or rolling stock. Disadvantages. It can be awkward because it doesn't have a particular on-off. Its output is relative to the amount of light shining on it. So unless you put in some electronics to it, you're going to get a varying light, which can be a problem. And our little kit has got a trimmer, so you can adjust for a home layout. You have to do the same thing if you went to various exhibitions, but it can be a bit of a pain unless you have proper shielding. And there's my trusty meter again. Done nothing to it. I've just put an LDR under the track, and you'll see when a train comes along, sudden drop in the resistance because you've blocked the light to the LDR. Same again. So we can use that effect to detect when a train has passed, or if I was to stop the loco right over that LDR, it would be a constant low resistance during the time it sits there. Mostly we'll do something like that. We'll feed it into a transistor, which in turn will give us a current boost. Or we can change the configuration. If you use a 547 instead of a 557, you get a better probably switching effect. But that's the basic one there. The LDR TOTI, you'll see it embedded in the track. In that example, very, very cheap. It's a good beginner's kit. It's got one trimmer to set the sensitivity of it, depending on your own particular layout. In that case, it's only lighting up a LED, but in the real world, that LED would be coming back to a mimic panel, whatever. It wouldn't be on the module itself. Remember that one? That was the LDR sitting under here. If you want, you can replace the light with a relay. And right away, we've got ourselves a new animation. The train comes into a factory, goes over the LDR. The relay can switch a higher current device like a motor, and the conveyor belt starts running. So as long as the wagons are sitting in that siding, the conveyor belt constantly runs. When the train shunts out again, the conveyor belt stops. A little localized animation just by train detection. That's simply replacing the existing LED and its dropper with a relay and a diode, a bypass diode. I mentioned this one already, automatic signals. Also a kit, also very cheap. In this case, it's doing LEDs for lighting, but we can also, if we wanted to, instead take the output to an easy point. So when the train comes along, it operates a semaphore arm rather than operating lights. The options are there, just add together various kits. Another popular train detector, infrared. We use that a lot. Infrared, there's the frequency of it there. It's not visible. It's used a lot. You have it maybe in your own garden. Keep out intruders. The light comes on when a human comes close to it because humans radiate infrared. They are affected a little by ambient light for that reason. So they're used in modern layouts, but they tend to be shielded to keep out unwanted light. They're low power devices, which is handy. And you can buy them, you see it in a pair there. That price is for 2 3mm. To the right of it, you can also buy SMD versions. And in fact, we use the SMD versions in one of our layouts because they're so much smaller. 3 types, as you see there. The first one on the left is a simple photodiode. In other words, the resistance here changes with light across it, and therefore the voltage here is going to vary up and down depending on the light level. So the output is going to change. The phototransistor is the same idea, except you've got a gain. So you get a bigger swing coming out here. And a Darlington version has got 2 transistors, so the gain is even greater still. And you can buy them in these different types. And we use them a lot. There's a very, very basic one. On one side, we have the infrared source. The other side, we have the infrared detector. And if you break the beam in between, you change the amount of infrared that's been transferred across, and it's spotted and will tell you. So it's basically a beam breaking exercise. They're very, or used to be very commonly used in computers. The very early mice, if you remember, the ball underneath the mouse would roll and it would spin a disc. The disc has slots in it, and the slot, the disc would rotate in that channel there. So it'd be breaking the light, not breaking the light, breaking the light, not breaking the light. So the more you rotated it, the amount of signal coming out here would either be a fast stream or a slow stream. And that's how you knew how far your mouse had rotated in one direction. And if you use 2 of these at right angles, you can go to any position in the plane and get an output stream. They're also used still for like CDs and DVDs and so on to detect whether the tray is in or out. So you have the detector, the beam going across, and then the caddy can come in and block the light, or the caddy can come out and let the light shine through, and you can detect whether a particular mechanical piece is in or out of that plane. So there's a very simple one, just beam breaking again. Let's just see it working. This time the train has got a little assistance from my finger. But you'll see as it breaks the beam, the lead goes on or off. Extremely simple, very, very small component count. When you're doing beam breaking, you'll see this commonly mentioned in journals and so on. You don't do what we've got to the right. The very right shows a beam going straight across the track. And that's fine if all you want to do is get a single pulse to initiate something. If a device only needs one pulse changed to start a whole activity, that's fine. But if you're trying to, for example, detect a train to keep barrier gate closed, then you can't have it, as you see on the right-hand side, because what's going to happen is you're going to get gaps between each of the bits of rolling stock. So it'll be on, off, on, off. You're going to get pulses all the time, and you don't want the gate to be wiggling. So what you do is you put the two at an angle. The source of infrared and the detection of infrared are at an angle, so you always get a blockage during the whole procession of the rolling stock. And that's the beam breaking method for infrared. One of the members is using it in a fiddle yard that's got multiple tracks, so you have to put a set of these in each part so you know which ones are occupied. The other method that we commonly use is reflection. Instead of breaking the beam, we send the beam out and bounce it off something and see what comes back. And we use those tiny little devices, the TCR T5000, which are 20 odd pence each. 4 pins, 2 of them are for the infrared source, 2 of them are for the detector. And they can handle 100 milliamps, operate at 5 volts very handily. What do we use them for? Well, there's a very simple single detector. Let's just see it working. I'm going to first of all use a dark source. It didn't switch, did it? Because there wasn't much reflection there. The light source works happily. So the light's coming from the source, bouncing off the white paper, coming back to the detector and changing the output. Right, there it's there. You can do a little demo. It's also a very handy tool, by the way. If I just switch to the desk, if you've got a remote lying in your drawer, TV remote, and you're not sure whether it's working or not, you can just get your TV remote, press the button. Yep, that one's working. Every time I press a button, it flashes. If you want to, you can go back to the idea of having a bistable and have two detectors like that, feed into a bistable. And here we have 2 of those TCRTs, 1 at each end, and an output. And if I was to put that white card on a train, you can make the LED switch. So it latches to one output and then unlatches. Right, while we're on about reflective detection, you'll see there's a TCRT or its equivalent. Some people take the TCRT out of its case because that's only in a plastic case. It's only 2 individual 3mm components, handily set up to be just at the right angle for best reflection. But you can take them out if you want to save space. And we're reflecting off the bottom, in this case, of a wagon. There's the original Hector kit. You get your own infrared source and phototransistor to detect it. It works over quite a range of voltages. It can handle up to 50 mil of distance if you're using white. It's got a high current output and relatively cheap. But now we've brought out this one here, which is a dual Hector. Exact same process, but you're connecting 2 infrared sources and 2 detectors for £8.93. You can get that in the kit locker. And it works on the basis of reflection. Here's a very crude example we rigged up The train comes past, the light comes on the building. The light stays on because one of the options of the Hector is when you detect something, does it detect it instantly and then drop out? Or if it detects it, will it stay on for a little while? In that example of that video, it stayed on for a little while. We've used that option. So the Hector's using reflections off the loco as it passes. The 4A is an add-on to the simple shuttle, so that instead of going back and forward, it can go into a different siding each time. I can just show that working. To make that work, it needs to have a detector. So I ran this speeded up to save time. So right now, so that little loco the tank came in. Now the centre cab's going out. So each time it switches the point to a different position. But it's got to know when it has arrived so it can switch the point, because the length of track here in this little demo is only a couple of feet, but that could be 20 feet in a big layout. So it has to know when it's arrived. And you'll see here, we've got the TCRTs. There's one there, there's one behind for the other. So it knows when the loco comes in here. So we're using reflection in that example. That's all there is to it. 2 TCRT 5000s, each feeding into a PIC which controls the point, and a little pot to decide what delay they're going to allow between a loco coming in and getting out. Here's an extended example one of the members brought in to show us. Does the same thing, except he's added in the auto stop in the middle. So one train comes in, the auto stop stops at the next station for a predetermined time that the user sets. And when that time expires, it goes to the other end of the track. The shuttle time takes over now, and when the shuttle time expires, that loco is going to come back across, and a different loco will come out from the other siding. Same thing, only with, in this case, it's a 00, and it's used an auto stop in between. I won't play the whole thing just to save you. I'm going to sit and wait, gents. Right. Now, that's reflection. But the reflection you saw a moment ago was from a stationary point, you're detecting moving objects passing by. What if we reverse that round and we say, we put the detection on the moving object, and it reflects off stationary objects, in this case, the track. So if we're able to bounce the signal from an infrared source off the track and come back up again, we can see whether there's any changes. In this case, if there's no, if this bit of rolling stock is stationary, you'll get approximately the same level of reflection every time. But if it's moving, it's going to jump between sleeper, ballast, and it doesn't really matter whether it's concrete sleepers or wooden sleepers, whether the ballast is grey or whatever. As long as there's a difference in colour between the two, it'll know it's moving. And the detector will spot the changes in light level. If they're above a certain amount, it'll then trigger the lights inside the coach. In other words, that's the basis for the automatic coach lighting kit. You'll notice it's the same TCRT 5000, hardly any components, a 3-volt source, and it lights up 3-volt LEDs, and is very cheap. So it's still using reflection, but the opposite of what we normally think of it. There's a circuit. Couldn't be simpler really if you tried, I don't think.